All right, so we're going to use properties of logarithms to simplify and also to expand. Logarithmic expressions. So there are actually 3 of them, similar to the exponent rules. We had a product rule, a power rule, and a quotient rule. If you remember, we also have negative exponents. These are called properties. So the product property tells you that if you are having a log, doesn't matter what the base is, of 2 numbers being multiplied together, you can split that into 2 logarithms with the same base being added together. So for example, log base 2 of 2x would be equal to log base 2 of 2 plus log base 2 of x. So that would be used to expand it. Now, if I were to give you this, you could simplify it backwards to the original. So again, if you're multiplying things together within what you're taking the log of, when you split it, you keep the base the same and you add them. Okay, the quotient property says if you have 2 things being divided, you can split that into 2 logarithms that are being subtracted. Which kind of is like your exponent rules where you'd subtract the exponents if they're being divided. So it's kind of similar. Bless you. So for example, log base 2 of 2 divided by x could be expanded to be log base 2 of 2. And you always do the numerator first and then subtract log base 2 of x. So these are equivalent expressions. One is expanded, one is simplified. And the last one is the power property, which says if you're taking a log of a value being raised to a power or an exponent, that power can move out front and change to multiplication. So let me give an example of that. Log base 2 of x to the 3rd power. This can be simplified. The power, again, will come out front and become a multiplication of, so this would be 3 times log base 2 of x. Now what gets hard is when I start combining all 3 of these properties in one problem and asking you to simplify or expand. But we'll start out really easy, just identifying the property or properties used. So our answers here are going to be product property, quotient property, power property, or a combination of 2 or more. So this one we see log of 6 equals log of 2 plus log of 3. Is that our product property, quotient property, or power property? It allows us to split the 6 into 2 and 3 and add them. Jade? Product. Okay, taking a product, breaking it into 2 factors and adding them. So this would be our product. And I'll just abbreviate property, prop. Okay, the next one says log base 5 of 2 minus log base 5 of 6 equals log base 5 of 1/3. What property is that? Abby? Quotient. 2 divided by 6 is 1/3. So it's technically quotient property and a little bit of simplification, but that's not a property, so. All right, now the next one, we're going to have more than one property showing up at a time. So we have an exponent, which is telling me I'm probably going to have the power property. I also have a quotient, which will mean I have the quotient property. So let's see if that has been done correctly. The 2 has come out front, so that would be my power property. And the division has been split into subtraction of 2 logarithms, so that would be my quotient. So 2 properties at once. You could have all 3 technically as well. What properties do we see in the next one? This one's a little tricky. Jade?
Quotient property and power property.
Quotient property and power property. So this 3 is out front, which means it would go back up to being an exponent. And this 3 also would go back up to being an exponent. And then since they're being subtracted, that would be division. Which would be 64 divided by 8, which does get us 8. But you don't have to show the work for this, but I'm just kind of explaining as I go. So this was our power property and quotient. Alright, so the directions on the front are going to be to simplify and rewrite as one logarithm. On the back, they'll change to expand. So it's either whether you're taking one and expanding it out, or you're taking the longer part and working backwards to simplify. But it's all using the properties from above. So, and double check, they do have to have the same base. So if this were log base 3 and log base 2, you wouldn't be able to combine them. So sometimes the answer can be not able to be simplified. But we have the same base. We see the numbers are being subtracted, which means that we can write this as one logarithm using division of the quotient property. And then we can simplify 12 divided by 4 will get me log base 3 of 5. You do not have to evaluate it. So you don't have to set this equal to x and then find out what x is. They just want you to simplify as one logarithm. Now the next one, we see a number out front being multiplied. So that's your power property. I would always do my power property first. So this will go up to be an exponent. Again, check to make sure you have the same base so that you can use any of the properties, and we do. We have a 2 and a 2. So if you're adding 2 logarithms, that means you're multiplying together what you're taking the log of. So this would be log base 2 of x cubed y. And if you want, you can put that in parentheses. You don't have to, though. See if you guys can try the next few, and then we'll go over them. If they asked you to evaluate, the answer would be 1. We'll do that on the back. 4 to the x power equals 4, so 4 to the first power. But we'll see that on the back. Now this one, we had a power rule and we had a product rule. So first, you always want to do the power rule. So move that 6 up to an exponent. So this will be log base 5 of x to the 6th plus log base 5 of y. And then if you're adding them, we multiply. So this would be log base 5 of x to the 6th y. 9 was the hardest one. It had all of the properties in one. Power, product, and quotient. So again, you always want to do the power rule first. We'll move that up here. So that becomes 2 to the 3rd. You want to evaluate what 2 to the 3rd is. So that would be log of 8 plus log of 4 minus log of 16. You do want to go in order from left to right, just like you would read using order of operations. So we'll multiply these first to get log 32. And then we see subtraction, which is division, so we'll get log 2. Now this one doesn't have a base, or does it? When there's no base, what is the imaginary base? The implied base, Caleb? 10. It's called your common base. So if you don't see a base, it's just assumed to be a 10. And then for our last question, it says, can you write this expression as a single logarithm? Sam? Good. No, because the bases are different. I don't remember if there's any on the homework. There are a couple that cannot be simplified. So always keep that in mind, that you want to check the bases before you move on. All right, now on the back, we're going to switch directions. We're going to say expand, which means write it out as multiple logarithms added, subtracted, multiplied together. So the first one would be using our quotient rule in reverse. So we will break this into subtraction. Log base 5 of x minus log base 5 of y. Now, when you have more than one, you may want to do it in multiple steps. Like the next one, I see that these are being multiplied. which is my power or product rule, and I see an exponent. So I'm going to split this up first to be log 4 plus log P3, e to the third. Then use your power rule and take the 3 and move it in front as a coefficient. So it'll be log 4 plus 3 log P. So you always want to expand it using all the properties as much as you can. What would the next one be? Log base 2 of 7b. When I expand that out, what will I get? Garrett?
Log base 2 for 7 plus log base 2
Good. Multiplication goes to expansion with addition. Now this one we have parentheses with a squared outside. So you have two options. You can either put the 2 up front now, or you can split up the 2 into be y squared and 3 squared, which is probably what I suggest to do, because otherwise you're going to have to distribute later. So I'd probably say it'll work either way. I can show it both ways, but you might want to go ahead and just distribute that to be y squared over 3 squared. And we know 3 squared is 9, but since we're expanding it, we're just going to leave it with exponents. I probably would accept either answer on your quiz, but this would be log of y squared minus log of 3 squared. And then we'll use the power rule to move our exponents out front. So this will become 2 log y minus 2 log 3. Now if you were to not distribute to begin with, you would end up with 2 log y minus 3, or y divided by 3. And then this would be 2 log y minus log 3. And then you would have to kind of distribute that 2 out. So it's kind of easier to do first. See if you guys can try 15 and 16. And then we will take a look at some natural. And the last one should have been the easiest one of all. Probably Sam?
Log base 17 minus log base 7.
Good. That was just the quotient rule. It didn't have any more than that. All right, so the properties of logarithms will also always apply to the natural log, which we said was ln, natural log is ln, of x. Remember from our calculator, that was the button right below it. The natural log is a log with a base e, but we write it as ln of x. So all of the properties that we talked about on the front for regular logarithms work for the natural log. Instead of having to check their bases, you'll know that if they say ln, the base is e, so they can use all the properties. So if we're adding, we can multiply. So this would be the natural log of 9 times 2, which is 18. Now this one we have power and quotient. So move this 2 up top, move this 3 up top. So we'll have natural log of 8 squared minus natural log of 4 cubed. And so we'll get the natural log of 64 divided by 64, which would just be the natural log of 1. 8 squared is 64, and 4 cubed is 64. And then the last one, we do have some parentheses. So, a couple ways that you can do this. We do want to use our power rule. You could also distribute it. Trying to think what the easiest thing for you guys to do. Doesn't really matter. Now, since this is still outside the parentheses, you do have to kind of give it out to each one. And maybe we want to combine this first. Why not? So when we add 2 logarithms, that's when we multiply those. So that'll be xy, but that'll be parentheses to the 1/3. Quantity to the 1/3. Minus, this 4 will go up top, so the natural log of z to the 4th. And then at the end, we can divide those. So it'll be natural log of xy quantity to the 1/3 power over z to the 4th. You could also distribute and make it x to the 1/3, y to the 1/3, but they both would need that power. All right, the last set of problems, we're going to use the properties and we're going to evaluate. So again, evaluate means to solve it, get an answer for what that value is. And we are going to do these without a calculator. So you could actually solve each one separately and then subtract them, but it's much easier to simplify them first, then set it equal to x and solve. So for this one, double check, our bases do match. So we'll have log base 2 of 4/16, which you can simplify down to be 1/4. And if the directions just said simplify to be 1 log, that'd be your answer, but they want us to evaluate. So to evaluate, we set this equal to a variable, x, and we change to exponential form, which is to take the base, raise it to the power of the other side, and set it equal to what you were taking the logarithm of. So this would be 2 to the x equals 1/4. So anytime it goes from a whole number to a fraction, we know that it's a negative exponent of some sort because it's dipping to our denominator. What would the value of x be? Ashley? -2. Therefore, the answer is -2. Next one we have power and quotient. So again, always do the power rule first. Let's move this up here. So that'll be 2 to the 3rd. So that's going to be log base 2 of 2 to the 3rd, which is 8, divided by 4, which is log base 2 of 2. You guys will notice that whenever the base and what you're taking the logarithm are the same, the answer is 1. But you can prove it, set it equal to x, and change to exponential. You'll get 2 to the x power equals 2. So the answer is 1. How many of you think this is easy? Okay. Why don't you guys finish all of these with a partner and then bring them up for me to check, and then I'll give you guys your homework and you can work on that. Since you have 3 and 3 to the 5th, this is really 3 to the 1st, right? So whenever I multiply these together, I'm going to get 3 to the 6th. You don't have to find out what 3 to the 6th is. Watch. Set this equal to x. Change to exponential, so this will be 3 to the x power equals 3 to the 6th power. So x has to be 6. That will save you from having to do multiplication off to the side and then thinking what root gets you there. So if you can leave it in exponential form, if this was without a calculator, it will help you. I think that might be the only one on. Alright, I wanted to go over these last few examples for any of you that might be struggling. For number 36, we should notice that we are adding 2 logarithms with the same base, which means we can multiply those numbers together to get the log of 100. 1 times 100 is 100. Now they want us to evaluate. So remember that if there's no base there, it's an imaginary base 10, and we'll set that equal to an unknown. Change to exponential form, so this will be 10 to the x power equals 100. And you have to think 10 to the what power gets me 100, and that would be 2. Okay, the next one we also see addition, which means that we can multiply these 2 numbers together and condense this down into 1 logarithm, log base 6 of 36. Again, to evaluate that, we'll set it equal to an unknown value, and we'll change to exponential. 6 to the x power equals 36, and therefore x has to be 2. The next one has power and product. So when you see these numbers in the front, you want to go ahead and put them back up as exponents. So this will get me log base 8 of 4 squared minus log base 8 of 8 to the 1/3 power. 4 squared is 16. Now you do have to use your prior knowledge that the 1/3 power is the same thing as a cube root. The cube root of 8 is 2. So now we have two logarithms being subtracted, which means we would divide them to get log base 8 of 16 divided by 2, which is 8. Evaluate that by setting it equal to x, and we'll get 8 to the x power is equal to 8. Therefore, the answer is 1. Okay, last you get a little bit even more challenging with multiple properties being displayed. So again, take our coefficient out here, move it up to the exponent. So this is 3 squared, which is 9. So that'd be log base 3 of 9 minus log base 3, 3. When we're subtracting, we can use our quotient property to divide 9 by 3 to get log base 3 of 3. Evaluate that by setting it equal to an unknown. You will notice that when the base and what we're taking the logarithm of are the same, it will just get us 1. But you can show it by changing to exponential. We will get 3 to the first is equal to 3. 2 more. Again, take our coefficients and move them back up to the exponents. Again, when you see a 1/2, remember that's the same thing as the square root. The square root of 1 is just 1. So this is log base 5 of 1 minus log base 5 of 5 squared, which is 25. And if we're subtracting, that means we can simplify this to be division. Log base 5 of 1/25 will be our simplified version. Now let's evaluate that. Set that equal to x. Change to exponential. 5 to the what power gets me 1/25. And anytime you see a number going into a fraction, that's a hint that this is going to be a negative number, which will get us a negative exponent. Therefore, it'll move to the denominator. So think 5 squared is 25, so this has to be 5 to the negative 2. And our last one. No power, but we do have a power rule here, so we'll throw that up here. So we have log base 9 of 1/3 plus log base 3 of 3 cubed, which is 27, not 81. Okay, now we have addition, which means we can multiply these together. So 1/3 times 27 is 9. Oops, I have a little typo here. It should be log base 9. So we can multiply this together to get log base 9 of 9. And we'll evaluate that, setting it equal to x. We will get 1. Your homework is the 8.4 worksheet. Again, on the front, it's going to ask you to condense. In the back, I think it says expand. So make sure you follow the directions.